I want to do is, so I started recording. Okay, so first I just want to review, just do a few problems that I think I'll help with the quiz. And then I'm going to talk about one new algorithm, Shellsort. And Shellsort is really just kind of a generalization of insertion sort. So remember, insertion sort, we're kind of looking to the left. Well, here, well, let's just look at the examples here. So I kind of had some examples that I did in the other class. So why don't I just open that file up originally right now? So I'm going to share the screen. I'm going to share this Word file. Okay, so so let's just start. Okay, so the first, okay, so for we can, the examples I did last time had strings. There's no reason why we shouldn't sort with. We can't also sort an array of integers with these algorithms. Let's just try an array of integers with a selection sort. And the thing about selection sort is, unlike insertion sort, you can like jump right away to the, what does the array look like after iteration 5 or iteration 6? Or let's say you had like 1,000,000 elements, what after iteration 1,000, but you can't selection. I mean, yeah, selection sort really, you have to start from the very first iteration, or else you'll never, because there's all these big jumps or potentially big jumps, which you don't have in insertion sort. So let's just remember that what what I like to think of as selection sort. I think it's like you're looking for every iteration, you're looking for the global minimum of the remaining array elements. Okay, so there, like we have that array, and I think you can see it 6, 4, 11, 3, 15, 9, and 4. Okay, so then the very first iteration, yeah, I'm not popular. I mean, if you're hearing myself, it says all these alerts. Okay, so the very first iteration, what we do is we scan the entire array. We're looking for the index. We're looking for the index of the absolute smallest value, and we're going to, exchange, that the location, the value at that index with the what's at position 0. So let's just see here. It's pretty clear. I think humans just definitely have this advantage that we can just immediately almost look at this. Oh yeah, it's a small amount of numbers. The computer will look at it one by one. First, it can only see the 6 and then the 4. Okay, so let's see. So after iteration 1, so what do we have here? So we're going to have, okay, so we're going to, so what we're going to have, so the 3 and then the 4 and then the 11 and the 6 went where the 3 used to be. Okay, so let's just highlight what was exchanged. Okay, so what do we do here? So exchanged x of 0 and x of 3, right? Because position 3 had the absolute smallest value, because the first iteration, that's what we're looking for. Okay, so now okay, so we'll do a couple of these. Okay, so maybe we'll just do the whole thing. So after iteration 2, okay, so now what we're doing, so in iteration 2, you're looking from positions 1. So let's say here's your array. This is after the first exchange. So we always start. Okay, so let's say here's your array. Okay, and so the 3 is the 3 is in its, the 3 is set, right? Okay, so okay, so we have the first smallest because of the, okay, so we found first, I'm not sure that's the best English, first smallest, so the absolute smallest. Okay, or the absolute smallest value. Okay, so that's, okay, so we know position 0, 3 is in its proper place. So now what we do is we look at we're going to find the smallest among the remaining elements. I'll just kind of highlight this in this green for right now. Okay, so we assume the smallest is at position 1, and then we keep scanning, and then we scan the rest of the array. And actually, it turns out 4 is the absolute smallest. So 2 values that are equal. So 4 is not less than 4, right? So we're seeing, is there anything less than x of 0 is 4, the smallest is at position, no, x of 1 is 4. Okay, position 1 is the absolute smallest, and no other element is anything smaller than 4. Okay, so what we're going to do, so it turns out we actually don't have to do an exchange. So I'm just going to convert this, so we'll write this down here. So let's go back to this kind of blend. Okay, and so this is so what do we do here? But you actually do the exchange. The code will actually do the exchange. So we exchange x sub 1 and x sub 1. Code actually does it. So found the first two smallest values, absolute smallest, right? So 3 and 4 have the absolute smallest values. And now we just, so there's 7 values, so there's 6 iterations. So we can maybe go a little bit faster. Okay, and just stop me if you have a question at any point, or if at any point you need to leave, that's fine. I'm going to do this whole lecture just so it's recorded. Okay, so after iteration 3, okay, so let's just kind of blank this. Let's turn this into some kind of blank. Okay, so now, so the first two so the first two are in its correct position. So now we have to scan the remaining values to find the next smallest, or the third smallest value. Okay, so we kind of, so you scan there, and it turns out that the last 4, there's actually 2 4s in there, so that's at position 6. We're going to exchange position 2 and position 6, and I haven't actually written this yet. Found first 3 smallest values. So the 4 goes here, and the 11 goes here. So we made that exchange. So let's just show so what's in red will be the values that were exchanged. It doesn't look like red. Okay, so now the first, so 3, 4, and 4, they're in the right place. And so then we have to find the next smallest of 16, 15, 9, and 11. Okay, so let's just keep going here. We're almost done. Okay, so exchange, so these 3, okay, so let's just make this. Okay, so now we're going to find the smallest of these, the ones that are in green. So we have to find the absolute smallest. And it turns out, oh, look at that, it's 6. 6 is in it's 6, and it's in its proper place. So we exchange x sub 3 and x sub 3. Find first 3. Okay, and so okay, so this will become, let's just show which ones were exchanged. And the only thing that's it, so the code actually does, even if when you're exchanging with the, the exact same value, it doesn't do an exchange. It's kind of unnecessary. I mean, the only way to prevent it is put an if statement in. That doesn't necessarily, it's not necessarily even any more efficient. Okay, so there's 2 more iterations. Okay, so this will become, okay, so now what we have to do is find, okay, so the first 4 are, so after iteration 4, the first small 4 are in its proper place, like 3, 4, 4, and 6 are in its proper place. So then we find the smallest value of what's in green, which is 9. So we exchange x sub 4, right, and x sub 5. Is that right? Yeah, 1, 2, 3, 4, 5. Yeah. There's 5. And once you found the first 6 smallest, then the 7th one is automatically the largest, the last one remaining. Okay, so this is a 9. That's a 15. And these have become red. We exchange those. Okay, so then there's one more. So iteration 6, it's actually the last one. So if you look, we just have to make sure, okay, which is there's only 2 values left that we have to compare. And that turns out to be, we have to compare 15 and 6. No, I'm sorry, 15 and 11, I apologize. We have to compare 15 and 11. Okay, so, and once we found the smallest of those, we can actually see it. The only thing that the computer knows that there's two numbers that still have to be compared. And so we find the absolute smallest. And after we do that, we find the absolute smallest of those two values, 15 and 11, the ones in green, and for that row labeled iteration 6. But the thing is, then there's only going to be one value left that has to be the largest. So, so if the length is 7, the number of iterations is 6, and the number of iterations is always one less than the array length. So we're going to exchange x of 5. We're going to exchange 15 and 11. And so what do we get? So this becomes 11, and this becomes 15, and then we're done. Right? So now we've sorted the array with selection sort. 5, 6. So any questions on that? And so, knowing, but definitely in this quiz, before you start the quiz, just make sure you know the difference between selection and insertion. So you don't want to have to, studying during the quiz is not necessarily the best strategy, even though you have a fair amount of time to work on it. So if there's no other questions, so let's see here. So last time we looked at insertion sort. Now, to me, so the first problem we'll kind of review what insertion sort is. But we actually talked about four. First of all, we talked about 4 sorting criteria. So like the one we just did, we went from we had the array of integers. So of course we just use the natural ordering. 1 is less than 2 is less than 3. So the built-in ordering of strings in Java is dictionary ordering. The earlier you are in the dictionary, the smaller you are. And I'm assuming that we're using all the strings are made of the same case. Okay, so I think of insertion sort as more, you're just kind of, it's more of a local sort, but let's just see what happens. Maybe that'll help motivate you or make sense. Okay, so we have that array called Z, and you see it has 7 strings in it. Yeah, door, zoo, building, books, hat, dogs, and telephone. So the first time, we're going to do the first iteration. We sort the first 2. So that's the way insertion sort works. Okay, if you just have an array of just one value, it's automatically sorted. So what we're going to do is we're going to sort the first 2, and then we're going to sort the first 3 values, and then the first 4, and then the first 5, and so forth. But let's say you're putting in, let's say there's 4 elements. You've sorted the first 4. And now you're going to sort the first 5. Well, if the first 4 are sorted, maybe kind of speeds up inserting the next one. It's just more efficient. Okay, so now let's just do this just to remind ourselves here. Okay, so and it turns out, let's look at this. So we're going to sort the, okay, it won't be true of the second iteration, but let's do this. Okay. It turns out when we sort the first 2, because it's all we're doing in insertion sort. The first iteration sorts the first 2 values. And it's already, in this case, it's already sorted. There's nothing to do. Though it's still considered an iteration. If I said, okay, what's the state after the first iteration, you would write this. So, what you see there, the door, zoo, the fonts don't actually change colors, but the same strings. Okay, so now the second iteration of insertion sort using dictionary ordering, alphabetical, what we think of as alphabetical order. Well, you sort the first 3. You want the first 3 to be sorted. Okay, so that's the goal here. So let's say we have, this is our array, and we're going to make sure the first 3 are sorted. Okay, so everything after building stays the same. But if you're going to write the state of the array, you have to write the array elements that haven't changed at all. So what we're going to do is our goal is just sort everything to the left of that bar I put in there. And then everything to the right stays the same. Now, as it turns out, door and zoo are already sorted. So now we're going to put building to its proper place. Building looks to the left, and building is less than zoo, so it exchanges with zoo. And it turns out building is less than door, so it exchanges with door. So we're not going to show all the exchanges. There's something called Shellsort, which we will for one of the problems. So it turns out that this is just so now it's sorted in its proper place. I mean, now it's told the first three are sorted. The first three of the original array are sorted. So first iteration one, sort the first two. And then iteration two, sort the first three. And so gradually you're building up. The strings in red, take up more and more. First there's two of them, now there's three of them, then there's going to be four of them. But gradually you're just gradually building up sorting the whole array. Okay, so let's do now the one advantage of insertion sort over shell sort is that, well, in terms of at least giving a problem on a quiz, how's that? I'm not sure it's such an advantage, but the one thing we do know is that we can go directly to the fifth iteration, right, or any iteration. Now, we couldn't do that with selection sort because remember, the fifth iteration will sort the first six of the original array. And that's why I have that. Here's my comment. Yeah, first six values of the original array are sorted after iteration 5. Okay, so you just take the first 5 values, and of course, by the time you do the fifth iteration, the first 4 are already sorted, right? First, it's the first 2 are sorted, then the first 3, then the first 4. Then you get to the fifth iteration, you're actually sorting the first 5. But basically, what we want to do is, okay, so let's say I was starting from the original array, and I was just sorting. Let's say this is like a quiz problem. What I'm saying is, you could, on a quiz, you can just say, oh, here's the state after iteration 5. So what we'd have to 1, 2, 3, 4, 5. So everything from dogs, everything to the left of hat would not be sorted, and everything to the left of that bar would be sorted. And so we know it's building. We know it's building door. Am I doing that? Oh, then books. Oh, books. Books is less than building, right? Books, building, door, zoo, and then hat comes in. I think that's right. We'll fix this. Oops. You just have problems with the. Okay, there we go. Yeah, see, the first 5 are now sorted. Hopefully I did that right. We'll correct it if there's an error. Yeah, books, building, door, and then hat, and then zoo. And then the last 2, dogs and telephone, well, we haven't gotten around to sorting those yet. But so after the fifth, oh, wait a minute, I apologize, I did this wrong. After the fifth iteration, the first 6 are sorted. Okay, that's wrong. Okay, let me just start this again. I apologize. Okay, so let's just start. Okay, so there's 7 values. So the first 6 should be sorted after the fifth iteration. I apologize. Yeah, the first, okay, so that's the original array. And okay, so it's actually so telephone is not included in the sorted list. Okay, so because the first iteration, the first 2 are sorted. The second iteration, the first 3 are sorted. After iteration 5, 6 values, and that was my comment, 6 values of the original array are sorted after iteration 5. So it should be books, building, is this. And the zoo would come at the end. let's put door here, or dog's door. And now, yeah, that's better. That's 6 values. So the first, so yeah, so books, building, dogs, door, hat and zoo. Yeah, those are the first 6, and they're now sorted, I believe. And then telephone, in iteration 6, you would put telephone in its proper place, and you would put it. So what would happen in the very last iteration is iteration 6 is that telephone would be compared to zoo. We'd see that telephone is less than zoo, so you would exchange zoo and telephone, and then telephone would be compared to hat, but telephone's greater than hat. We just stop. Okay, so yeah, sorry about that error at iteration 5. Yeah, I sorted the first 5 instead of the first 6. But here's the point that I'm trying to make, which I maybe hopefully didn't get lost when I made the error. We have our original array Z, door, zoo, building, books, hat, dogs, telephone. And what I'm saying is we can jump directly to iteration 5 of insertion sort, right? What you do is you just take the first 6 values, everything from door to dogs, and sort them by alphabetical order. So I don't have to start from, so if I said, okay, what are the contents of the array after iteration 5? You don't have to start from iteration 1 and do iteration. I've seen students do that. They just start from scratch. And maybe I'm saying, okay, maybe what's the 14th iteration or some, I'm not sure if I ever gave a problem that big, but there's no, we can get to the like an intermediate iteration without having to start iteration 1 with insertion sort, but harder with selection sort because of all the jumping from maybe from the beginning way to the end. So if there's no other questions here, why don't we just continue here? Okay, so let's do 4th iteration, and we have 3 other sorting criteria, and then we'll talk about Shellsort. And okay, so 4th iteration of insertion sort using reverse dictionary ordering. So reverse dictionary ordering is you just go backwards. Like zebra would be the smallest. Like Z is less than W. Z is less than Y is less than X is less than W. A would actually, any words that start with A would be, bigger than any other words. But yeah, so the words at the beginning of the dictionary are bigger than words at the end of the dictionary. So that's what I mean by reverse. Okay, so now the thing is, reverse dictionary. So we're saying fourth iteration. So I'm not going to make that same mistake again. That means the first 5 strings in that array have to be sorted, and then the other strings just stay in the remaining place. And we're doing this in reverse dictionary ordering. And you know what, students, we could actually just use the previous answer and just kind of go backwards. No, that's using the yeah, we can still use it. Yeah, so the first 5 sorted are, let's be careful here. 1, 2, 3, 4, 5. Let's just be careful. I don't want to encourage bad habits. So this is our original list. And those are the first 5 values. I'm starting from the original array: door, zoo, building, books, hat. Okay, so what we want to do is the 4th iteration would sort those first 5 values. So I'm just going to now try to take a shortcut here. We're doing reverse order. So it's zoo. So that's the biggest one in that list. And then I think the next biggest one is hat. Right, because we're going in reverse order. And then it's a door. That's not where I want my cursor. Door. And then building and books. And then we have to write the entire array content. So, okay, so then we write dogs and telephone. Yeah, so the first 5 are sorted in ascending order. I mean, descending order. The first 5 are sorted in reverse dictionary ordering. right? Zoo. So we looked at we took the first 5 values in the array and sorted them in reverse dictionary ordering. And the rest of the values stayed the same. So any questions on anything, just call out if you have a question. Now we're going to do the same, well, the same array: door, zoo, building, books, hat, dogs, telephone. And we're going to start talking about length. Now, when we talk about length, just totally ignore the contents. Just think of the strings as, map all the strings to numbers, like door is 4, zoo is 3, building is, I think it's at 8, books is 5, hat is 3, dogs is 4, and telephone is something, it's 9, okay? But when we're talking about length, you just think of it as a number, and we're going to sort these numbers. Okay, so once again, we're going to use the 4th iteration using length in ascending order. Okay, so it turns out, oh, the other thing, remember when like zoo and hat, they both have 3 characters. So so zoo is equal to cat. So I just want to talk about it. So maybe I can write it down here. So I'll fix it. Yeah, so the string zoo has 3. We're talking about, we're just talking about, all we care about is the length method. What numbers return from the length method? So therefore, if we're considering length, if we're comparing by length, zoo, that's just 3 is equal to hat. Right? They're considered the same. So we don't reverse the reason I bring this up, let's just look at the original array. Let's kind of scroll down a little bit. Okay, so the original array is right here: door, zoo, building, building, books, hat. Okay, zoo appears before hat. If we're going from left to right, zoo appears before hat. We don't exchange them. Even though zoo, if we're looking at contents, yes, but we're not looking at contents. Right now, all we're looking at is length. So don't exchange strings that have the same value, right? So like when we compare, like if we're putting hat in its proper place, we're looking to the left, and we compare hat and zoo, hat is not less than zoo. So we would not exchange hat and zoo. So you only exchange elements, you only exchange a string if the string to the left is smaller. You only exchange a string if the string to the left is bigger. Right? Because you're trying to put all the small ones at the beginning and all the big ones, big strings at the end. Okay, so so what do we have there? We have 4, 3, doors 4, zoo is 3, building 8, books 5, hat 3. Those are the 5 that we're looking at, the 4th iteration. So we're going to sort the first 5. So the smallest is zoo. That's the first smallest, and now it's hat. Okay, so door has 4. I think door is the next one. So this has 4 characters. And then books has 5. And then building would be the last one. Okay, so wait a minute, we're not done. Then you have to list all the remaining. You have to make sure to include all the remaining strings. Yeah, the rest of the array doesn't change its order. What am I doing? Okay, there we go. That's better. Yeah, I'm not great at Microsoft Word. Okay, so the first 5 are sorted in. Okay, so the first 5 are sorted in ascending order by length: 3, 3, 4, 5, and then 8. And then the last 2 have not been put into the sorted list yet. Okay. Yeah, if you're going to put dogs into a list, you would put it. You would actually put it to the right of door, because dogs and door are equal to each other. because they both have 4 cars. We're just talking, if all we're talking about is length, when we talk about length, we don't talk about contents. Okay, so the very last one. So let's, we're going to sort in descending order by length. So we know what, okay, so basically we're going to have to sort zoo, hat, door, books, and building in descending order by length. Make sure we look at the original list to see the order of the strings. Okay, so once again, these are the 5 because it's iteration 4. The 4th iteration of insertion sort if we're comparing in descending order by length. Okay, so building is the largest. And once again, zoo and hat are equal to each other. So we would not exchange them. Zoo is going to appear before hat in this list. We're going in descending order. So it'd be building has 8, books 5, door 3, door 4, and zoo and hat each have 3. Okay, so you're descending order by length. Okay. It's almost the opposite of what we see there, except that zoo and hat don't change their position. So let's put first all the 8s. So no 7 or 6 character words, books, and door. And now this might be a tricky part for some. Some students might, I mean, I've seen students kind of reverse, and then dogs. And then telephone is the last one. And now we've sorted in descending order by length. Okay, so the leftmost value is considered to be the smallest value. So building is the smallest. Of the first 5 strings, building, if the criteria is descending order by length, of the first 5 strings, building is the smallest because it's got the most characters. Books has 5, doors 4, then zoo and hat has 3. So it's descending. 8, 5, 4, 3, 3. So any questions on that, Jose?
No, it seems straightforward.
Okay, yeah, hopefully. Sometimes I can't tell you, sometimes I'm talking, am I making this worse? Sometimes I do. Okay, so, okay, now the exciting shell sort algorithm. I'm going to do an example, and then we're going to just look at the, kind of briefly look at the code. I might skip some of the slides. And I think that this example just might help quite a bit. Because shell sort's really, it's not really that, first of all, shell sort has nothing to do with shells. And if you've had, for people who've had calculus, it has nothing to do with the shell method. There's actually some guy named Shell, somebody named Shell. I don't know if it's Donald Shell, and I don't know if he ever did anything else, but he's famous because we talk about the shell method. So, and all the shell method is, it's kind of a generalization of insertion sort, where instead of looking one to the left, so insertion sort, it puts, it wants to know if a string, is in its proper place. It looks to the left. If the string to the left is smaller, there's an exchange made. So what shell sort does, instead of looking one to the left, it looks h values to the left, where h is some positive integer, and we choose what h is. So I have this example, some of it's typed up already. So here's my example. Okay, so here's the example. Shell sort. Okay, so let's sort easy question with shell sort. And we're gonna, and what we're gonna do is we're gonna sort every 4th character. So what I did, now if you can see that, I changed the font size, not the font size. I changed the font color. So it's blue, like look at easy. It's blue, red, green, black. And then I just repeat that with those same 4 colors. So like Q is Q is blue, U is red, E is green, and S is black again. Then we go back to the blue, T is blue, I is red, O is green, and N is black. So, and so what we're going to do is we're going to sort the characters in the same color group. So we're going to sort, the blues are, EQT, and then the reds are A, is that right? The reds are AUI, there's only 3 of them. And the greens, there's only 3 of them, S, E, and O, is that right? Oh yeah, wait a minute, S, E, wait a minute. Do I feel like 1, 2, oh right, there's 3 groups. I'm sorry, I apologize. Yeah, there's 3 groups. I'm obviously a little bit tired. Okay, there's 3 groups. Yeah, there's 3 blues, 3 reds, 3 greens, and 3 blacks. Okay, so the blues are EQT, the reds are AIU, the greens are the characters in SEO. We see those are in green, and the characters in the black font are Y, S, and N. And now what we're going to do is we're just going to sort them. So like if you sort EQT, that's already sorted. And then, sorted, what do we get? If we just sort the blues, well, it's AIU, right? And if we sort the greens, it's EOS. And if you sort the characters in black, so what do you get? You get NSY. Okay. And so we're actually gonna, so let's just put those, so let's sort it, and well, we're gonna keep the same groupings, right? So, we're just, so we're only going to replace a blue character with a blue character. So EQ and T stay in the correct place. So we're going to sort. E is at the first E is at position 0, index 0, and then Q is at index 4, and then the T is at index 8. So we don't change the indices. So EQ, the sorted EQT puts in indices. Yeah, so sorted. This is already sorted. It's EQT. So, and it's located in indices 0, 4, and 8. And so the reds are indices 1, 5, and 9. And so what we basically have these four independent, and so this is at indices 2, 6, and 10, right? 10, 10, 10. And then the black characters are indices 3, 7, 3, sorry, 3, 7, and 11. Okay, so okay, so we have that. Okay, so we have these 4 groups of characters. So we have 4 groups, and there's 3 in each group. Okay, and they don't change what indices. So like the reds are going to stay in indices 1, 5, 9. The greens are going to stay in indices 2, 6, and 10. Okay, so now we're just going to sort. Okay, so this is kind of, and I did it here. It's kind of pre-sorted. I just kept it from the last lecture. But if we just look at the blues, so this is kind of a critical part of Shellsort. We had easy question, and what we're going to do is we're going to sort every 4th character, like 0, 4. What's at 0, 4, and 8, and what's at 1, 5, and 9, and what's at 2, 6, and 10, what's at 3, 7, and 11. And so we can just verify. If you just look at the blue characters in the final answer, it's E, Q, and T, assuming I put everything in the correct column. And let's look at the red characters. Are they sorted? So let's just look at 1, 5, 9. Yeah, those are sorted. A, I, U. And then the greens, let's look at the greens, 2, 6, 10, E, O, S. And then the one in the characters in the black font, you start, it's 3, 3, 7, and 11. Yeah, we see that they're sorted. So it's kind of a check right there. Okay, so now we're clearly, now here's the thing, it's not sorted, right? It's EA is not sorted, it's AE, right? I'm using natural ordering of characters. What you have to do is this iterative process. And then, so now you would do the same thing over again. Okay, we start with the sorted list. We have this, it's sorted every 4 characters. Now let's sort it every 2 characters. Now let's do, let's say for 8, H equal to 2. Okay, so we'll just use 2 fonts, red and then the black font. So we did, so after sorting every 4, okay, we have EA, EN, QIOS, TUSY. Now let's kind of color code that so it's red, black, red, black, red, black. And then, so what do we get there? We get, so what's in the red? It's EE, let's see, EE, I think I left one out here. Let's see, EEQ, I left out the O, right? Is this what I left out, the O?
Yeah.
T, and then, oh, wait a minute, yeah, let me do this again. Oh, I put the O should be after the Q. There should be, yeah, there's 12 characters, so each group should have 6. I did it for the other one too. EEQOTS. And then in the black, the group of black font characters, it's ANISUO, and then there's a Y at the end. Okay, and they're not going to change their, so the red characters are at the even indices, and the black font characters are at the odd indices, and we don't change that, right? So we keep them in the same group that they originally came with, and so now we're going to sort them. So it's E, and I left out the O. Okay, so somehow I left it. That's great. EI, yeah. So there's what happened here. EIE, and then it's a Q, and then okay. So let's start. I'm going to start this again. Trying to fix this. Okay, so it's E, and then Q, O. What was it? And then an S. And I think yeah, Q comes before O. NOPQ. Okay, so we're going to sort that. Sorry. This is why I give out the alphabet. It's for my purposes, not for the students. Okay, Q, S. Okay, so the red characters are sorted, and now let's interleave it with the characters in the black font, and let's make sure they're sorted. So it'd be A, and I think the next one would be I. Let's make sure this is in black now. And then the next one would be I. It's kind of hard to do in Microsoft Word. And then, okay, so the A and the I, and then I think the next one is N. And then we need SUY. So then, and then the S would go here. And then the U would go here. And then the Y would be in the very last one, last position. Okay, so now notice the one thing is this. I don't think this is, sometimes you might get lucky and it's sorted. Okay, so it's still not sorted, right? N is actually should be to the left of O. I think that might be the only problem. No, and the T should be the left of U. So it's still not sorted. So first we sort every fourth, every group, every fourth one, and then we sort every other one. And then if you really want to make, we're not going to do it. If you really want to make sure it's sorted, now you have to sort, then you just do regular insertion sort, right? Then you would do insertion sort, and then it's guaranteed. You have to look directly to the left. You can't like sort every fourth one and expect it to be sorted, or sort every other one and expect it to be sorted. You have to actually, look at do it like we did for insertion sort. You have to, you have to consider you put all basically you give every character the same font color and sort. Okay, but what's the advantage of shell sort? So first of all, shell sort, you still ultimately, to make sure it's sorted, you have to do insertion sort. Okay, but what's the advantage of doing these preliminary steps, like the one where we sort, like the easy question with like the 4 different colors, blue, red, green, and black. What was the advantage of that? Well, first of all, I'm not claiming there is one. It works, it can be useful if the array if it's really unsorted. If you know for a fact that it's very unsorted and you have a lot of like big elements on the left and a lot of small elements on the right. Okay, so shell sort, because we're sorting every fourth one, what it does is maybe it moves some of the bigger values all the way to the right sooner. And first of all, I don't think it's really a widely used algorithm. I'm not sure it's actually used at all. It's hard to, just by reading from the Sedgwick book, not from my own personal experience, Sedgwick will say it's really not hard. It's a difficult algorithm to analyze in terms of like order of growth. A lot of times it depends on the input. He's done some research on that. So, but it's not that important. I think it's because we're supposed to learn it. It's because it's one of these, there's algorithms that no one really uses that much, but they're kind of classic algorithms. Insertion, selection, shell sort. And the 2 big ones that people actually use are quick sort and merge sort, which we'll learn soon after exam 1. So, Any questions on this? I thought we could actually look at the code and then do, just do one quick worksheet problem. This is not going to be on any kind of quiz. We'll review this again next Monday. But so why don't we just do the, let's just look at the code and then we'll look at a worksheet problem. And then it shouldn't take too long. So I need around another 10 minutes or so to finish this. Okay, so I'm going to stop sharing for a second. I'm not sure, I might have my grade book open for one of the courses. I'm just going to stop sharing here for a second. And I'm not quite sure what I have open. Okay, so I will, let me tell you, I'm going to just, should be more prepared. I'm going to download this file. And files. So let's just use that same PDF file we looked at last time. I'm just going to download this. Okay. Hopefully everyone's still here. So let's just share that. And then let's close this. Let's close this. And I want to go here. I want to go to my downloads. Okay, it's opening up. It kind of takes a while sometimes. We're only going to look at a few slides here. It's not really that big a document anyway. Okay, so let's open up. Okay, yeah, if I talk to the document, maybe it'll work. Okay, so let's see here. It's funny how impatient I am because I was thinking how like when I was like in college, kind of like your age, this would have been like beyond. This would have been like the Jetsons. I don't know if you've ever seen that show. They're flying around in like their own rocket ships, and they live in the air. Have you ever seen that? Anyway, that's what this would have seemed like to me. And I'm getting so impatient with it. We had like the crudest. I mean, you wouldn't believe how crude the equipment was then. Okay. Anyway, no one had their own computer. You worked like there was a central building, and all the students went there, and you worked all hours. I mean, like 3, 4 in the morning, because that's the only place you had to work, and everyone shared resources. Anyway, so much for that interesting conversation of mine. Okay, so let's go down here. Okay, let's go to Shellsort. Let's just look at the code just for a second here. So first of all, here is this, if you remember, here is the code for insertion sort. And remember, this was the key thing here. It's this, remember that method? It's a code that Sedgwick or one of his students wrote. And it's true if the value in A sub j is less than the value in A sub j minus 1. And so remember, we're looking at if A sub j is less than its neighbor to the left, then we exchange. A sub j is exchanged with A sub j minus 1. So that's why we have to check if j is greater or equal to 1, because you don't want to, you can't, in a position 0, can't look to the left. You'll get a negative index and your program will crash. Okay, so then, now let's just look at Shellsort. And Shellsort is almost identical. This is really a variation of that. I just have to find the code. Okay, so it's right here. And okay, so first I'll kind of forget about, okay, so this, again, I got this from Sedgwick's book. So like this stuff here and this right here. So Sedgwick kind of has this strategy. Like, remember how the original problem, we went every fourth one. And so Sedgwick has this strategy like for picking the original gap. So we had a gap of 4, which I just chose, nothing special about 4. So that's what his while loop is about. So his gap is about n. So if the length of the array is n, his gap will turn out to be about n over 3. Okay, but all I care about is this nested for loop. This is Shellsort. The while loop is just a strategy for picking the gap. Okay, and so notice that there's only, what's different about this? So h is your gap. Like in that example we did with the 4 colors, h was 4. So you actually start at I equal h. And so we'll look at an example in a minute. And then when you look to the left, instead of looking directly to the left, you look like h values to the left. So if h was 4, we'd look 4 values to the left. And if a sub j is less than its neighbor, the fourth neighbor to the left, you make an exchange. And then you subtract H from J. Okay, so I think it'll help if we look at an example. But basically, so it kind of looks like insertion sort. But instead of like -1, we were going -H. Okay, why don't we look at an example and then we can see maybe how this works. Okay, so my cat is very insistent on. So if I still have the writing here, I'm going to erase it. Okay, so I used to actually put the entire code on the when I would give a quiz, and let me make this a little bit smaller. I would actually put the code on. The students were like, hey, when you put the code on there, well, I would put the code on. It didn't change the students who were prepared didn't need the code, and the students who weren't prepared, it didn't help them. Okay, but I would put it on there anyway. So there's the code. And I remember I had one student who was really good. And he never studied. And so when I would put the code on, he would just use the code and get the answer. So it helped him. Okay, so we're going to do a few rows of this. So there's our original array, and all the strings have one character in it, like Z, E, E. So that's what you should be seeing right now. You should be seeing a document, and you should be seeing string str, and that kind of array with like 12 values in it. Z, E, E, D, D, C, C, so forth. And we're going to sort using Shellsort. And we're not going to do all the steps right now. Well, I just want to know maybe the first 4 or 5. Okay, so and our gap is going to be 3. So the gap is, so we're going to sort every third value. So like we would sort, I'll just do one of them, like Z. So in the end, we know it's going to be like Z is 0, so that's 0, and then at 3 there's D, and at 6 there's C, and then at 9 there's Z. Okay, so at the end, at the final step, we know that those 4 should be sorted. We're not going to have a sorted array, but it should be sorted every third character. Okay, so let's just use the code. And so what Sedgwick does, and I think this is what most people do it, is that, okay, so we're gonna start by putting, okay, so the D, so if this is just insertion sort in these 4 characters, we'd put the D in its proper place. We compare D to Z. So that's what we're doing. We're gonna start H at 3, so I starts out at H. So the first character we're gonna put in its proper place is D. We're gonna start right here. And so let's see if I can, so let's just see if we can, maybe there's some symbols I can mark the groups here. Okay, so it's 0, 3, 6, and 9. And then I'll put X's for this, then it's X 4, 1, 4, 4, 7, and then 10, right? And then it's going to be 2, and then 5. Hopefully I didn't make a mistake. 8 and 11. So every third, yeah, I think it's every third one. Because I'm not sure how much that helped. Okay, but what Sedgwick does, he's going to go from group to group. So first he's going to put the D at position 3 in its proper place. Then to put the D in position 4 in its proper place. And then put the C at position 5. So there's actually 3 independent sorting problems. So he's going from like group to group to group. He goes, sorting problem 1, then the first character in sorting problem 2, then the first character in sorting problem 3. Oh, let's go back to group 1 and sort the second character. Okay, so but he does it, but he goes through the array, literally. He starts at 3 and then 4 and then 5 and 6. Okay, like the Xi book, I did this course last year with the Xi book, and they do it differently. They actually just sort like a whole group. They would sort like 0, like the ones that are underlined, 0, 3, 6, 9. I'm not so sure. That's actually probably less efficient. It might be easier to understand, but I think it's less efficient. Just jumping around an array can be inefficient. Okay, again, for our problems, it's so small, we never really know. Okay, so let's just look at the code, and we're going to put this D, the one that's at position 3 in its proper place. And you go 3 to the left. That's what, so in this case, our H is 3. And so our J starts out at 3. So initially I is 3. Let me do that one more time. Initially I is 3. And then your J is 3. And okay, so you compare what's at position 3 to 3 minus 3. So we're going to, so we compare the D and the Z. D is less than Z. So this is what we, and I'll circle what we, so sorry, that's going to be a D. So we exchange these two, and then everything else stays the same. So there's at most two, there's at most two characters that are exchanged. So we exchange the D and we exchange the Z. Okay, so now we go to 4, right? And we go 4, no, we go 3 to the left, and we're going to compare what's in position 4 and position 1. Oh, and so D is less than E, so let's just put the D here. And let's put the E here, and then everything else stays the same. And once you make a mistake, it's hard to recover. And I have made mistakes. As soon as student once point out like a mistake in my solution, I went 4. I was starting out at 3, and then I started doing 4. Well, that's not good. Okay, so let's see here, and it's easy to make that kind of mistake. Hopefully now that I said it, I won't make it. Okay, now let's go to, oh, our favorite is when we get to 6, and we put the character in position 6, and we're going to stop. Okay, let's put the character in position 5 in its proper place. So I is now 5. So J is 5. We compare A sub 5 and A sub 2. Well, C is less than E, so we exchange. So C, and this is actually what the Shellsort, I kind of like this problem because it really forces students to show that they understand what Shellsort is doing. So we exchange the C and the E, and then everything else. And now we're at 6. Okay, so I like this one because you're going to see we're going to have 2 jumps. So you keep looking to the left until you can't exchange anymore. Okay, so at position 6, there's the C, and we're going to compare now. We're going to compare A sub 6 and A sub 3. Okay, so C is less than Z, and so we're going to put the Z here, and we're going to put the C here. Let's circle them, and now let's put the rest of it in. Okay, so now the C that was originally in position 6 is now position 3. I circled it, but we still have to look 3 to the left. Okay, so now we compare A sub, so what would this loop do? It subtracts 3 from J, so J was 6, now J is 3, and so now in A sub 3, so we compare A sub 3 with A sub 0, C is less than D, so we do another exchange. So yeah, so when we do Shellsort, when we put like we were trying to put this, so originally we were putting that C in position 6 in its proper place, and to do that, you might have to do 2 jumps. Basically, we just did 2 iterations of this inner loop right here to put that C at position 6 in its proper place. And then I think we should stop before I make a mistake. No, but I think you can see that you can try this on your own. Putting the B in position 7. Well, let's just show. We're not going to actually do this, but let's look at this. So it's 7. There's a B, and it's and the D there's a, because the gap is 3. Okay, so the 7 has a B, and then we go 3 to the left, we get a D, and then we go 3 to the, oh, wait, do we, yeah, we move these though, so sorry, students. You're the only student, okay. It doesn't actually matter. Okay, so my point is here, so we're position 7. So what's in position 4? So position 7 has a B, and now because we did the exchange, the position 4 has an E, and the position 1 has a D. Right, so you can see that B is less than both E and D. So when we put this B at position 7 in its proper place, we're going to have to do 2 jumps again. I'm not, I swear I'm not torturing her. It sounds like it. I think it's the other way around. Okay. Okay, and the same thing for the A. How many characters? You start at A and you go, how many, look to the left of A, you go through the left. So there's a C and an E. So when you put the A at position 8 in its proper place, it'll take 2 jumps. And I know that without even, before I actually even make the exchanges. Now let's look at the last one, position 11. Okay, so 11, okay, so how many jumps would we need to, so 11 would look at 8 and 5 and 2. So there's an E, so there'd be 2, there's an E and then a C and an and an A. So there's actually, so that C at position 11 is only less than the E at position 1, right? So if I look at 8, so I look at the group of 11, 8, 5, and 2. So that's an E, C, A, and C. So when I put this C in its proper place, how many are less than C? And it's only that E. So to put that C, by the time I get to that C, it's going to be 1 jump. So anyway, so much for that. Okay, so so do you have a question? Now, one last thing. I know I keep talking. This A would require 3 jumps. Like for the A, so A would be, you'd look at 7, 4, you'd look at, I hope I didn't make a mistake. Okay, so the 10, 7, 4, 1. Okay. Wait, put that C in its proper place. I wonder if I looked at the right group. Oh, yeah, I looked at that's right. There's an E and 2. Okay, so let's say the 10, so 10, there's an A, position 10, there's an A, 7, there's a B, originally, 4, there's D. So position 4, there's a D. What's in position 1? There's an E. Okay, so that A at position 10 is less than B. It's less than the B at position 7. It's less than the D at position 4, and it's less than the E at position 1. So when you put that 10 in the A at position 10 in its proper place, it's going to require 3 jumps or 3 iterations of that inner loop. So, and I know that even before we start iterating, all you have to do is look to the left and see how many are less. And that's the number of iterations it's going to take to put that character in its proper place. So hopefully that last part wasn't too confusing. We're going to review this also again on Monday. And I'd like to have maybe one other kind of, maybe some kind of smaller topic that I can also introduce on Monday. But are there any questions right now, Jose?
Do your files have the H different, like H of 2, H of 4, H of something else? Because I feel like I feel like it's understandable. I guess.
I think I have one. I'll take a look. I have one with 5, one with 4, and one with 3. I don't think I have any with 2.
All right, I guess I'll look it up.
Okay, I'll look at some of my old quizzes, and that's I didn't do any, like in the quizzes. All I'm doing is H equal to 3, right? I just wanted the students to show one. What are all the exchanges for one value of H? But again, at the end, you're not sorted. You eventually have to do H equal to 1 to guarantee that it's sorted. But yeah, some of my old quizzes, I did an H equal to 5, H equal to 4, and H equal to 3. So let me look at some of my old quizzes and I'll find them.
Thank you.
Okay, so but anything else right now?
I'll probably just do one of your worksheets and then email you it.
Okay, so I'm gonna, yeah, definitely it's good to try these. But anyway, at least we went through this, and then I'm gonna stop this sharing if that's okay. And I'm gonna stop the recording.